All right, so as you see, once we've already found our equation and we were able to get our constants for B and our constants for A, and to see what they actually look like, we get, give me 1 second. We get A is equal to 9/8 RTC, which is our constant times our temperature at a critical pressure multiplied by our volume at a critical value. And then we have our pressure, our van der Waals equation from the beginning, which is R of temperature at critical of our V critical minus B minus A over VC cubed. What we do now is we actually want to input our A and B right back into our equation so we can find our compressibility factor, so that once we find that, we won't have to do all these hard complications all over again. So let me just go ahead and do and our B constant is equal to VC over 3 minus A, which is 9/8 of RTC over VC over VC squared. So to get started, and this all equals P, to get started we see that we have a VC 1/3, so we're going to make that 2/3 of our critical volume. And then over here, you see that we have VC on the bottom and VC on top, so one can go away. And we have a 9/8, so we're just going to redistribute that, so it's 8/9. And we have 2/3 for our constant volume, so we're going to redistribute that, so it's 3/2. I'm going to rewrite the equation so we can have a better picture of it. Well, alright, so let me show you real quick. So now we're going to have P, I'll get a different color, just so it's easier to see. We're going to have P is equal to 3R times our temperature at a critical value over, we have 2/2 of our critical volume, and that's going to be minus 9/8, because 9/8, 8 times 9, of RT at a critical volume over VC. And what you see is that we have RTC, VC, and VC on both sides. So what we can actually do is we combine these into one equation. So let me get rid of this for you real quick. And we are going to get 3/2 minus 9/8 of and this is going to be our compressibility factor. So 3/2 times by 4, we get 12/8 minus 9/8, which gives us 3/8. So P is going to be equal to 3/8 critical temperature over our critical volume. And now that we have this, we're able to actually figure out pressure, volume, any of the sort using our compressibility factor without having to use the entire van der Waals equation states with our A over critical volume squared and our volume critical subtracting by our B. Thank you for your time.